Hi everyone. Welcome to the section Build Your First CNN and Performance Optimization. The first video is convolution and pooling operations in TensorFlow. Now that we have seen how convolutional and pooling operations are performed theoretically, let's see how we can perform these operations hands-on using TensorFlow. So, let's get started. First, we will apply pooling operations in TensorFlow. Using TensorFlow, a subsampling layer can normally be represented by a max_pool operation by maintaining the initial parameters of the layer. For max_pool, it has this signature in TensorFlow. Now let's learn how to create a function that utilizes this signature and returns a tensor with type tf.float32, that is, the max-pooled output tensor. We have used the previously described signature here. Run the code. Let's look at the parameters now. Value. This is a 4D tensor of float32 elements and shape. K-size. A list of integers representing the window size on each dimension. Strides. The step of the moving windows on each dimension. Data_format. NHWC, NCHW, and NCHW_vect_c are supported. Ordering, NHWC or NCHW. Padding, valid or same. However, depending upon the layering structures in a CNN, there are other pooling operations supported by TensorFlow. tf.nn.avg_pool. This returns a reduced tensor with the average of each window. tf.nn.max_pool_with_argmax. This returns the max_pool tensor and a tensor with the flattened index of max_value. tf.nn.avg_pool3d. This performs an avg_pool operation with a cubic-like window. The input has an added depth. tf.nn.max_pool3d. This performs the same function as, but applies the max operation. Now let's see a concrete example of how the padding thing works in TensorFlow. Suppose we have an input image X with shape 2, 3, and 1 channel. Now we want to see the effect of both valid and same paddings. For valid_pad, max pool with 2x2 kernel, stride 2, and valid padding, and same_pad, max pool with 2x2 kernel, stride 2, and same padding. Let's see how we can attain this in Python and TensorFlow. Suppose we have an input image of shape 2, 4, which is one channel. Now let's give it a shape accepted by tf.nn.max_pool. If we want to apply the valid padding with the max pool with a 2x2 kernel, stride 2, enter these lines. On the other hand, using the max pool with a 2x2 kernel, stride 2, and same padding, we have to enter this. Let's validate them. You will get this output. For valid padding, since there is no padding, the output shape is 1, 1. However, for the same padding, since we pad the image to the shape 2, 4, and then apply the max pool, the output shape is 1, 2. The next part is convolution operations in TensorFlow. TensorFlow provides a variety of methods for convolution. The canonical form is applied by the conv2d operation. Let's have a look at the usage of this operation. Now we will look at the parameters in detail. Input. The operation will be applied to this original tensor. It has a definite format of 4 dimensions, and the default dimension order is shown next. Filter. This is a tensor representing a kernel or filter. It has a very generic method, filter_height, filter_width, in_channels, and out_channels. Strides. This is a list of 4 int tensor data types, which indicate the sliding windows for each dimension. Padding. This can be same or valid. Same will try to conserve the initial tensor dimension, but valid will allow it to grow if the output size and padding are computed. use_cudnn_on_GPU equal to true. This indicates whether to use the CUDA GPU CNN library to accelerate calculations. Data_format is NHWC. This specifies the order in which data is organized, NHWC or NCWH. Dilations. This signifies an optional list of ints. It defaults to 1, 1, 1, 1. 1D tensor of length 4. Dilations in the batch and depth dimensions must be 1. Name. A name for the operation which is optional. Then we have an example of a convolutional layer. It concatenates a convolution, adds a bias parameter sum, and finally returns the activation function we have chosen for the whole layer. In this case, the ReLU operation, which is a frequently used one. Here, X is the 4D tensor input with batch size, height, width, and channel. TensorFlow also offers a few other kinds of convolutional layers. For information on those, you can refer to the reference material provided with the course.